Hi, everyone, and welcome to vBrownBag US, June 3rd, 2015. We are continuing on with our series of vSphere 6, and tonight we have Mike Wilson presenting. Just a few show notes first. Watch our other series, the APAC region, every Thursday, out in EMEA, Tuesday nights, the Latin American on Thursday nights as well, and of course the US version Wednesday nights. And follow us on Twitter, hashtag vBrownBag if you want to ask questions, hashtag vBrownBag, or raise your hand in the chat on GoToMeeting. And I am Lauren Malhoit, first-time host for vBrownBag, and we also have Imad Yunus helping me out here, so he'll be answering a lot of questions probably. And without further ado, I'm going to pass it on to Mike Wilson so he can get started.
All right, how you all doing tonight? Let me know if everybody can see that. You good, Lauren?
I'm good. I can see you.
Excellent. All right, first-time presenter here tonight as well. We're going to go over section 4, objective 4.1 of the VCP series here tonight. In that, we're going to go ahead and identify VM hardware versions and capabilities, access options. We're going to go ahead and demo creating and configuring templates, customization specs, and edit virtual machine settings. We're going to identify vApp use cases and requirements under Objective 4.2. We're also going to go ahead under 4.3, identify options to create and clone VMs, and discuss how shares, reservations, and limits work and use cases for them. We're also going to have a demo on that as well. And finally, we're going to go ahead and finish up with identifying the file locations of a VM, what they do, and how they're used. And we have a demo afterwards which includes configuring IP pools and creating a content library. So let's go ahead and get started into it. Objective 4.1, we're going to go ahead and identify hardware versions and capabilities. So what is a hardware version? A hardware version is a representation of the virtual machine supported hardware features. These correspond and change depending on the version of ESXi installed on the host or the version of ESXi you created the VM on. An example of hardware features that you can add include vCPUs, RAM, USB devices, CD-ROMs, and more. Flip my slide here for you. You can show a picture of all of the different things that you can add. The virtual machine we show here in the slide is virtual machine version 11. This is for vSphere 6.0, and these are a number of the things that you can go ahead and add to it. You can set a default hardware version for your host, cluster, or data center. It's easy enough to do. All you have to do is go ahead and right-click on that particular object in your navigation pane, and you'll have an option on your right-click menu to go ahead and set the default version. Once you go ahead and you do add a machine to a cluster, though, it is set at the cluster level and no longer at the host level. When you create that, you can create a new machine. You can accept that default hardware version that you've set, or you can go ahead and change that. You can possibly even use a lower version. One of the reasons why you might do this is if you go ahead and you're sharing multiple different versions of ESXi in your cluster or your data center. The reason for that is because if you create a VM with a higher version than the host you're going to run the VM on, you're going to be limited and possibly not be able to. You can go ahead and upgrade a VM later and upgrade the compatibility to support more features, but you cannot officially downgrade. The only real ways of doing a downgrade on it would be to go ahead and killing your VMX file, actually deleting it, and then creating a new VM and pointing to your old VMDK. The other method, of course, which is what VMware goes ahead and has you do, is to create a virtual-to-virtual conversion using their P2V tool, and that will go ahead and allow you to change hardware versions as well. So you can go ahead and tell what version of the hardware you're running by looking at the summary of that virtual machine. in either the web client or the C# client. On 6.0, the current hardware version is 11, and this is only compatible with 6.0 machines. If you were to try to vMotion this back to a 5.5 machine, for example, you would need to be using hardware version 10, and if you don't, then it's very possible that the machine won't run, especially if you're using some of the features that are only allowed under 6.0. You have a quick glance at the capabilities by hardware version here. So the hardware version 11 on vSphere 6.0 will go ahead and support up to 128 virtual CPUs, 4 terabyte of RAM, and 10 different NICs, supports USB 3 and 2, and also supports AHCI controllers, which allows us to go ahead and virtualize things that require that, such as Mac OSs. Going back to 5.5, that goes ahead and cuts some of our capabilities. We can't supply nearly as many virtual CPUs to it. We also don't have the ability of supplying as much RAM, but most of the other features do remain the same. We go all the way down from 9 to 8 and 7, and we go ahead and go down significantly in the features that we can go ahead and provide for. So now that we've gone ahead and set up our VM and we've applied all this different hardware to it, how do we go ahead and access it and use it? Well, there's a number of different ways we can do this. We can do this either from the web client, or we can go ahead and do this in the C# client. And I have pictures here on the slides of both ways we can get at it. There's 2 ways. In the web client there, you can actually click on the picture itself of the VM. That goes in, opens up a new tab, and has the console inside of it. Or we can go ahead and launch the remote console. This is VMware's newly released tool that allows us to go ahead and support different operating systems than they used to be able to. Currently, they have a Mac client, and they also have a PC client. And shortly forthcoming, they're going to have a Linux client available as well. Underneath the C# client there, you have the ability of right-clicking on the virtual machine itself and then opening the console, or you have the tab as shown up there. You go ahead and, just like you do in the web client, opens up another tab. This will allow us to go ahead and get into there. Now, if you do go ahead and click inside the console, go for it.
So is there still a 60 disk limit?
As far as SCSI disks, yes. You still have four controllers, of which 15 can go ahead and fit on each one. Now, you can still add more disks into there, but they have to be under different controllers. So you could go ahead and list it as a HCI controller, or you could go ahead back to even further and list it as an IDE controller.
So total more than 60 then?
Yes, you can total more than 60 altogether, but if you're just using SCSI disks, then it stays the same.
So what's the limit on AHCI then? That's what the question is more geared towards.
I did not check that. I believe it's 15 devices, but I would have to check to make sure.
Okay.
So I will go ahead and whoever wanted to know that for sure, I will go ahead and get with you slightly afterwards. I've got a good roll going on right now, and I hate to break that at the moment, but do not fear, I will not forget you. All right, so all of the client consoles will allow us to connect ISOs and other devices into it as needed. And once we go ahead and connect the console, unless it has VM tools on it, and we click inside of it, our mouse cursor is going to be captured by the VM for use. Once it is captured for use, the only way of getting back out of it is to hit Control-Alt. Once the machine has an OS on it and is configured, we can go ahead and use all of our normal tools, such as RSAT, RDP, VNC, whatever our weapon of choice is, to go ahead and connect to the machine itself. So let's see here. Now we come to our first demo. So in my demo here, I have an environment set up here, just here on my local machine. And the first thing we're going to do is we're going to create and configure templates. So we have the ability here of right-clicking on a running virtual machine or a shutdown machine. And we can do a couple of things to it. We can convert it to a template or export it to an OVF template, or we can go ahead and clone it to a template or a template in the library. Now, if you notice, if I go straight to template and converting it to template, it does not allow me to do that, because once a machine is converted to a template, it is no longer allowed to go ahead and power on. So I have to actually turn the virtual machine off before it goes ahead and gives me that option. So if I go ahead and do that here, now go back under template, those options are now no longer grayed out. If I want to go ahead and create that template, I can go ahead and clone this machine over. When I do that, I go ahead and give it a new name. Go ahead and list where I want to put it. Select a compute resource. Do I want to go ahead and host it at the cluster itself or one of the hosts? And then we are asked to go ahead and select the storage location where we want it to be housed. We can go ahead and change it here as far as if we want it thick provisioned or thin. We can also apply a storage policy to it. We also had an advanced button, which we'll go over a little later in tonight, on actually moving around the configuration and the hard disk files. So I'll choose there, go back to basic, shared, and finish.
Wait, are you using Avengers? Yeah, you are. I see a theme.
Yes, I do. All right, so if you noticed, I've created my template, but it no longer shows up. And the reason for that is because you don't see templates underneath your host and clusters. If you go ahead over to your VMs and templates, however, there's my template. Now, we have the ability of creating our templates in that, but we also need, if we have like Windows machines or Linux machines, we need to go ahead and go a little bit further. We may need to go ahead and reset SIDs. We may need to change the name on it because we may have a ton of these to go ahead and send out all at the same time. We can go ahead back here to the home screen, and now we have the ability of creating a customization specification. When we do that, it places those under the same policies and profiles as the storage policies and the host profiles. We can go ahead and set up to create a new specification. And we go ahead and list out what our target operating system is going to be. We'll say Windows, and we will call it Mike's Customization. And then I can go ahead and start going through the different options that I'll have when I go ahead and turn on the machine for the first time. So name, Mike, we'll say VMware is my organization. I can go ahead and set a computer name for it, or I can go ahead and use a virtual machine name that I have for it. Different options available to me. I can enter in my Windows license here. We'll move on from there. Administrative password. We'll go ahead and use the same one that we always do. All asterisks. Set a time zone. Any commands that I want to run after the fact. Standard network settings. If I want to add it to a domain, I have the capability of doing that. And then I can have it set a new SID. Once I'm done with that, I click on Finish, and I now have a customization spec. Now when I go back I want to go ahead and create a new virtual machine here. I can create that. It comes up with a beautiful little wizard here. I want to go ahead and deploy it from a template. Down here at the bottom, I have customized the operating system, and I can go ahead and click on that, and that allows me to go ahead and use my customization spec. Place it under there. We will call it Mike 1. Select my storage just like as before. And currently, that particular template is a Linux system, so I'm going to have trouble doing that. It's going to come back and say, hey, you need to go ahead and create a new customization spec. So I will go ahead and cancel here, but the only one after this was go ahead and complete it, and it will go ahead and create the new virtual machine and then run the customization spec first time we go ahead and turn it on. So the next thing we can go ahead and cover is edit virtual machines. And we do that simply enough by just going ahead and right-clicking on it, and we can edit settings. This allows me to go ahead and add any new devices that I would need to, and I can go ahead and change individual settings. I can add things such as a reservation on CPU or even CPU affinity if I go to the VM options. I can set reservations for memory and or shares. I can make changes to my hard drive. I can increase the size of it, change my storage policy, change shares, and even go ahead and use virtual flash read cache if I have SSDs available to me. I can also make changes to any of my other objects as well inside there. Last thing we'll go ahead and go over before we move on to Objective 4.2 is vApps. I've gone ahead and created a vApp here. vApps do require DRS underneath a cluster. So to make sure if you are trying to create a vApp underneath the cluster, DRS is set to on. But all you have to do when you want to create it is click on New vApp, and you can either go ahead and create a new vApp from your library or just go ahead and create one from scratch. I'll go ahead and take an existing one, which I have this test vApp right here. Go ahead and place it in the same spot. And I'll call it a clone of test vApp. Then provisioning. Any resource allocation that I want to go ahead and provide for that particular vApp. And then go ahead and finish.
All right, and we have
now I have an additional.
We have another question here.
vApp called clone.
Hey, Mike.
Okay.
So when would you create a vApp? Do you treat it like a movable resource pool?
You can. Typically, a vApp is more going to be used for creating a multi-tiered application. So if I go ahead and have a number of different virtual machines that kind of share a common link and need each other, they depend on each other, a vApp is what I would use for that. The reason why is because vApps are, which I'll go into a little bit more later in the session here, the vApps have the ability of changing your startup order. You can have IP pools associated with them, and you can even go ahead and as mentioned, go ahead and associate shares and resources to them. But generally speaking, the majority of time that I've seen it and seen them used out in the real world, it's going to be for multi-tiered applications and workloads.
Awesome, thanks.
Mm-hmm. All right. So let's go ahead and exit out of there. And we'll move into objective 4.2, which, fittingly enough, identifying VApp use cases and requirements. So what is a VApp exactly? VApp is going to be roughly a folder with intelligence. It's going to allow the packaging of virtual machines that you can compartmentalize and manage as a unit, or you can go ahead and take multiple VMs together and export them out as a VApp to go ahead and share with other locations or other companies even. You can do a couple of things with them. You can manage resources on them. You can also manage the startup order of the machines in the VApp. Keep in mind, of course, that everything you do to the VApp itself will also go ahead and have an effect on the VMs inside of it. So if you change your resources, or if you go ahead and you shut down the VApp, make sure that you're doing it at an appropriate time, or you may have some very angry users on your hands. The use cases, as mentioned before, would be your multi-tiered workloads. The intelligence is what brings it all together. The other nice thing about it, as mentioned, was the ability to go ahead and export a group of VMs together, and it goes ahead and it's kind of the glue that binds them all.
Mike, I'm pretty sure I saw you do this, but we have a question. Can you clone a VApp, or is it only import-export?
You can clone a VApp. Yes.
Yeah, we saw that when you right-clicked on it, right? That was an option.
Yes. And we'll go ahead and do that again in the demo. So we'll go ahead and see that again. So the one last reason, I believe it was mentioned before, was to be able to reserve or allocate shares of CPU or memory to the VApp to go ahead and make sure that you have enough resources for the VMs inside. So the VApp settings here, as mentioned, I show it both in the web client on the left-hand side there and the C# client on the right. You can apply an IP allocation policy to it, which we'll go over later in the brown bag. You can apply CPU and memory resources to it, and you can even go ahead and change the startup order. And we'll go ahead and show that as well. So now let's go ahead into our environment here. And I still have my clone VApp left over, but if we go to our edit settings for it, we'll go through the options here. In the CPU resources, you can set a reservation. You can go ahead and have an expandable reservation, so if it does happen to go ahead and run out of reservations, it can pull it from a resource pool, another VApp, or the cluster above it. Memory resources, relatively the same thing. IP allocation, it's going to be set up and partially down here as well. The VApp can obtain its network configuration through the OVF environment, and that's what this does. It allows us to go ahead and create a DHCP inside of there, or lets us specify what particular protocols that we have in there, and we can also go ahead and actually go even a little bit further if we use the IP network profiles, which is an extension of this back at the data center level. The start order was one last thing that we mentioned, and to better show this, I'll go ahead and move okay. Sometimes it refreshes, sometimes it doesn't. Go ahead and edit back in the settings now. And now you can see we have listed out in groups a startup order. If I had multiple VMs inside of there, it would go ahead and allow me to change the order of it. And then I have a number of options before I go ahead and start the next one. I can go ahead and set a number of seconds to wait, or I can go ahead and wait until VMware Tools itself that's loaded on the machine inside there starts communicating with vSphere before it goes ahead and starts the next virtual machine. So back by popular demand, we've already created and cloned one, but we will go ahead and clone it again. So we'll take that vApp there, clone an existing vApp. We'll create it underneath here, and we will call it a clone of a clone. Go ahead and select the storage, any resource allocation, and away we go. And now, as you noticed, my clone of test vApp, the clone of the clone, has the same VMs line underneath it as the original does. So just like you can export it, and when you export it, it exports the VMs out as well, you can go ahead and export and clone just within your environment itself, and it will still go ahead and work with the VMs as well. Now, if I was to go ahead and clone this out, I can export OVF template. I choose the directory that I want it to go to. We'll say documents. And I can create a folder of files or a single file itself. If I want to, I can enable advanced options, include MAC addresses, any extra configuration, and click OK, and away I go. After that's there, I can go ahead and check, and it is a massive 80 kilobytes. Not very much inside of it. All right. So that goes ahead and takes care of vApps. So moving on, we're now going to cover Objective 4.3, which is identify options to create and clone VMs, and also shares reservations and limits and how they work and their use cases. So, in order to work with all the different options that we have created right now, we have to have VMs to go ahead and populate them. So what kind of options does VMware provide to do this? Well, with our right-click menu, we are presented with Create New Virtual Machine, depending on where we actually click. And if we go ahead and choose the Create New Virtual Machine, it goes ahead and opens up into a whole list of options we can choose from. And here is that window here. So we can go ahead and create a new virtual machine, deploy from a template, clone a virtual machine to a template, clone template to template, and convert template to virtual machine. Create new is obviously creating from scratch. There's use cases for cloning templates to templates and also converting a template back to a virtual machine. Some of the use cases for cloning templates to templates might be to go ahead and create another template and then change it, which you would then convert the template back to a virtual machine and add some other piece of software to it, which then you'd go ahead and change that back. It could also be testing purposes. Converting templates back to virtual machines, as just mentioned, would be to go ahead and update the virtual machine itself. Cloning is also there as well, and we can go ahead and check that when we get back into the lab environment. It also exists directly on the right-click menu if you remember. So we can go ahead and clone to another VM template, or we can actually go ahead and clone to a template in the library, into a content library. Now when you go ahead and create the clone, and during the wizard, you can also change your hardware on it, and you can run that customization spec that we created, and even change the type of hard drive and how it is presented, as if it's a thick or a thin hard drive. So now, after we've done this, yes, we probably have a number of different VMs. Some of them are probably important, others not so much. So it would be nice for us to be able to go ahead and decide that and apply resources to them as needed. Fortunately, VMware has provided an option to do this. This is all part of the shares, reservations, and limits that we can provide and apply toward specific workloads. Workloads is probably a better word to use there, besides VMs, because we can also apply resource shares and limits to more than just single VMs. We can also apply it with resource pool, vApp, and later on disk and network resources as well. So let's go ahead and talk more about what each mean. Before, I have a picture that kind of discusses the difference between them. The reservations there at the bottom is going to be the amount of resources, whatever it is, that the VM has to have. It can go ahead and give that reservation up if it's not using it, but if it ever does decide to go ahead and use it, it will go ahead and grab that right back, and it has first dibs on those resources. If I have two different VMs that are both trying to vie for the same resource, then it is going to go ahead and use shares to go ahead and try to compete between the reservation and any limits that are applied. Limit is going to be a hard number at the very top that that VM or that particular resource is not going to be allowed to have more than that. And the problem with limits is if you set a limit, even if the resource is available, it will not go ahead and try to grab it. So we need to make sure that we're circumspect with our limits. Don't use them unless we have to. As mentioned before, shares specify the relative performance of a virtual machine, and so shares only make a difference when they're counted against total shares. Shares come into play if there's contention, so if everything is running along perfectly fine, you don't have to worry about shares at all. You can specify high, normal, low, and custom values for shares, and they can vary depending on the resource that you're assigning. Another thing to keep in mind is shares will be multiplied per resource. For example, if you assign 100 shares to a machine with 2 virtual CPUs, it will apply them to both of those virtual CPUs, and you'll end up with 200 shares of CPU. Memory is also done on the same way, and it is done on a per megabyte basis. So 10 shares on a machine with 1 gig of RAM, you'll have to go ahead and do your math here, which is 10 times 1024. It's going to end up with 10,240 shares. Once again, this is all relative to the total number of shares that are in that particular resource pool. Reservations are obviously, once again, when the virtual machine needs a certain amount to work and run, you can assign it a reservation. This guarantees that amount of resource, and if it can't supply it when you first try to turn on the virtual machine is not going to turn on. So use cases for using these can be many and varied. You can, depending on, for instance, on different organizational units. If one organizational unit goes ahead and supplies more of your financial bounty than another, you can go ahead and specify that that particular organizational unit will receive more resources than the other. Moving on, we got our demo
So
now.
we have a question, Mike.
Yes.
Okay, so the question is, but shares only take effect when there's contention for resources?
That is correct.
Okay.
So if there is enough resources to satisfy the needs of all the VMs, shares will never actually come into play. It's only when the host is being pulled down by the VMs that are running on it, and they're both fighting for those resources, will the shares come into play and signify and specify which VM is more important than the other.
We have a comment, don't do pools within pools. It gets really, really nasty quick.
Yes, it does. The other thing to keep in mind too is if you go ahead and create a resource pool and you go ahead and create, check that checkbox where it says expandable reservation, and there's really no way of limiting that because it goes back to the parent resource pool, then there's really no reason for you to create resource pools, period. So make sure that there is a certain amount of planning that is involved in figuring out who gets what resources. Otherwise, it doesn't make much sense. All right, so going back into my local environment here, we were going to go ahead and show configuration of VM resources, and I have mentioned that, yes, this is a short demo. So as shown before, we can actually go ahead and apply resources at a vApp level, but if we right-click on the VM itself, we can go ahead and edit resource settings. Go ahead and click on that. We can apply reservations, we can apply shares, and if there's any limits. So if we go ahead and choose high, we'll notice that there is default amounts of shares that are plugged in. And custom, we can go ahead and pretty much put any number we want in there. Now keep in mind that this is all based off of the total number of shares in our environment period, so it's really doesn't matter what number we put in there as long as we have the ratios set properly. Keep in mind too that there is a resource pool at this level. You just can't see it, but if you were to actually click on the summary, or the let's see, where am I looking for? Resource reservations, I believe it was. You can actually click on it and see total reservations, memory, and storage that's happening inside your cluster. And the actual parent resource pool is going to be an aggregation of all the hosts underneath. There it is, utilization. So total in this particular cluster, I have a total of 10.77 gigahertz of CPU available to me. I have 8 gig of RAM associated with the hosts. And then I can break it down even further into guest memory. All right, so moving on to our final objective. 4.4, we're going to identify VM files and location options used by the machine. All right, so I saw this picture out there on the internet and decided to go ahead and lift it with my sticky fingers because I kind of liked it and how it represented everything together. So the files, we'll start off with that. We have log files, and this is typically going to be represented by the actual VMware and then dash and then the number of the log. This is going to be a log of key VM activity. This can be useful in troubleshooting workstation problems. It even goes ahead and stores blue screens. You will have at any particular time up to 6 of them, and they are incremented as they go, and they are cyclical, and they are stored with the configuration file. The next one that I have listed here is the NVRAM, which is going to be your BIOS file. It stores the state of the machine BIOS. The virtual machine needs some type of BIOS, whether it be UEFI or the actual BIOS itself, and this is where it is actually housed in the file. So the VMDKs, this is actually a pair of files. VMDK, for most times, you're only going to see the actual VMDK file itself. There are places where you can go ahead and see the flat VMDK, and the flat VMDK is the second part of that, and the flat VMDK is where the actual data is housed. The VMDK file itself is merely a descriptor that specifies where the virtual disk begins and ends, how many sectors it has, and so on. Now, if you also have an RDM file, you will have an RDM .vmdk, and that will actually specify a particular LUN instead of a flat file. So you also have a VMSD file, the extension at the end, VMSD, and at the beginning of it will be the VM name. This will be the file that stores information and metadata on the snapshots that you have for the virtual machine. This can sometimes end up corrupted, and you can, if you're still running off of a snapshot, that will be where you actually need to do consolidation, snapshot consolidation. The VMX file is the config file for the virtual machine itself, and this stores useful information such as the hardware version, the number of CPUs, the NICs, what they're attached to, and so on. There is also a vSwap file. The swap file is basically kind of like a paging file, except for the VM world. This is going to be used and have a size attached to it if you have set a limit of RAM on a VM and you have not reserved it all. If you have reserved it, then your vSwap file will be usually 0. Finally, you have your snapshot VMDKs themselves, and that will usually be signified by the VM name, and then there'll be a delta, possibly a number on it, and a delta.vmdk. Those are the snapshot VMDKs themselves, and those are created when you go ahead and actually create a snapshot of the VM. So the location of these files themselves, oh yeah, I was going to show you what they look like inside. So the location of the files themselves are generally going to be in the same directory, but there is a few exceptions. You can go ahead and house VMDKs on different data stores for performance reasons. You can even house your vSwap on a different location from your VM as well than your VM configuration. And doing so might have other implications as well, whether or not you can vMotion, for instance. Is that swap file accessible by the host that you're trying to migrate to? So these are all things that we have to keep in mind when we go ahead and place them in different locations.
We have a comment there, Mike, as well. If there's no room for the vSwap file on the data store, the VM won't start. So something to take note of.
That is correct. And the vSwap doesn't actually go ahead and become populated. It doesn't actually have size until you begin begin that VM or start that VM. So that is one thing that you have to keep in mind when setting that and creating storage for each of the VMs. So if you create a 16 gigabyte RAM limit on a VM and you haven't reserved any of it, your vSwap file is going to be 16 gig of RAM additionally on your data store that you need. So, and if it can't satisfy that, yes, it will not start. One thing definitely to keep in mind. All right, so next, configuring IP pools and creating content library. First, a small definition on IP pools. The IP pools provide a network identity and can be used to supply DHCP addresses to VMs inside vApps. So inside here, as mentioned before, we can go into the settings of the vApp, which is the main construct that's going to use our IP pools, and we can set up anything differently here. But the other piece to this is back at the data center level. So if we click on the data center, go to manage, and then under network protocol profiles, this is where we actually go ahead and create an IP pool. Underneath the vSphere client, on the other hand, let me go ahead and pull that up.
It looks like we went back to your slideshow, Mike. Not sure if you intended that.
That's fine. I saw that. I meant for that to happen.
Of course.
Give me just a short second. My vSphere client is coming up as long as I go ahead and put in my proper username and password. Put in the old standby vsphere.local and forgetting that I had actually changed that. All right. Well, that's interesting. It doesn't show my, there it is. Scared me there for a second. All right, so underneath our data center there, we can go ahead to the IP pools, and this is where we go ahead and create a new IP pool and give it its properties. Go ahead and set the subnet for it, a gateway. We can enable it or not. There are some OVFs when we go ahead and the old vCenter operations manager would require you to actually have this when you went ahead and tried to start it up, unless you disabled the vApp options underneath it. And there's other OVFs as well that will go ahead and use this. You can go ahead and specify whether or not you set up DHCP on it, DNS, any sort of HTTP proxy, and then you associate it with a particular network. On this side, it's going to look relatively the same thing. You're going to the same way. You're going to start off by associating it with a network, though, and then you're going to have your IPv4, your V6, anything else such as your DNS, your host prefix, search paths, or your proxy. Get your summary page, click on Finish, and it will go ahead and create there. The final thing we'll go ahead and create is a content library. And if anyone has been following my Twitter, I had fits with this because this worked great on my laptop here, but not so well in my home setup, and I could not figure out why. Underneath here, I created a content library, and I actually had my templates, Control Center, and Linux underneath there, and had no problem at all deploying it and pulling it back out and exporting it back into a new VM. At home, I could go ahead and put it in my content library, but it would not come back out. If I was going to go ahead and create a new one, though, I just come back to my content library, and over here, I can create a new library. Go ahead and specify a name. And you'll notice first off that when you create it, there is no spaces or any sort of spaces between the words. It has to be all together. Specify a vCenter that you go ahead and want to host it on. Next, you go ahead and specify if it's going to be local or if it's going to be a subscription. Subscription is going to be if I'm subscribing to a remote content library, and I'm going to pull it down to a content library on my local vCenter. If it's a local, I can go ahead and tell it to publish the content library externally. I can also add a username and password if I want to by enabling authentication. Next thing I need to do is I need to specify its backing. Do I put in an NFS, or do I go ahead and use a data store for that purpose? Go ahead and click on Finish, and there's my library. I can go ahead from here, import an OVF package or other file type directly into the library, or if I go back to my home, host and clusters, if everyone remembers, if you right-click on that, a lot of my options were clone to template and library, or export OVF template, which then I could go ahead and use to pull back into the library. And that pretty much makes up my demo, and I believe that's most of what I've got. So at this time, I'm done. If there's any questions, and I haven't forgot about the AHCI, let me go ahead and do a quick search on that.
Yeah, that was awesome, Mike. And while you're searching on that, if anyone else has any questions, feel free to put them out there right now. Oh, we do. We also have a question. What's the real world use for IP pools other than pre-packages for vApps?
You know, I've never really seen anyone in my support history in the last 3.5 years really use it. I'm sure there's somebody somewhere out there that does. It's a really cheap DHCP server, but like you can get a DHCP server in just about anything. So, so to answer your question, I'm not sure. I don't really see that big of a use for it other than associating vApps with it and possibly using the DHCP to specify IP addresses to the VMs inside the vApp.
I think that's fair. They're also saying they have never seen them used in 5 years, and I myself have not really seen them used either. So we have a consensus.
All right. Excellent. All right, so the current implementation supports 4 controllers, AHCI controllers, and up to 30 devices per controller. So that would roughly give me 120 disks that I could go ahead and place off the AHCI.
Cool. And we have another question. Is the content library part of the vCenter or the PSC?
It's going to be part of the vCenter. And the platform services controller is going to take care and basically act as my Active Directory for VMware. So it's going to take care of all of my authentication, my certificates, and that sort of thing, where all of the rest of my goodies and that are going to be hosted underneath the vCenter service.
And your license.
What's that?
And your licensing.
Yes. Thank you.
Anytime.
Any other questions?
That's all I'm seeing so far. Maybe give it another minute or so.
Nothing on the Twitters.
I finished about 6 minutes early. I go through quick.
You're just an overachiever, man.
I apologize for that.
Let's see. Oh, we do have a question for you, Mike. How can I bench 150?
150? How much does he bench now?
I was going to say I'm at about 125, so.
I am more than happy to go over any of that stuff if you want. IT_muscle. Yes. Shameless plug.
All right, guys. Well, I think I'm going to call it. Thanks so much, Mike Wilson. That was an awesome presentation. And thanks to Ahmad Yunus for holding my hand through this. I appreciate that, too.
Sure, anytime.
And I think that's it for vBrownBag. Thank you all very much for watching and listening.